Hey everybody, today we're going to be building an intercooler. It's quite the core. It's 18 by 12 by 6. The first thing I'm going to start doing is laying out my tanks. And right now, this line up here is for my height. And then my inlet and outlet is going to be on these pieces. So what I did was I just laid out everything so I can cut it all at once. And what I'll be doing is coming up here, across, down, and the same thing for all four. So this would be the left side, this would be the right side, and then, you know, the front and back, front and back. Now we got our pieces cut out, sanded up. What we're gonna do is use this soft wheel, and this is for deburring. It's also really nice for polishing, you know, stainless. I wouldn't use on aluminum particularly, but works great when you want to clean the edges and get any small debris of the sanding belt that might have gone into the material itself. Gives you a really nice clean weld.
There's a lot of people putting black eyes in the game. You know what I mean? It's time to do this, man. But took a fall, now I'm off my feet. I gotta eat, so it's back to these fucking streets. And I will go cause I'm an old timer. I bring the drama to any nigga, his baby's always fucking mama. I gotta look like Tevin Campbell, but still I gamble, hustle and scramble. Cause money is muscles in this damn zoo. And in order to make it, you gotta take it. Beat up on blast, bruise, bend and break it, but don't fake it. That's why there's no guilt for these trife niggas' bloods I spilled. Took what they built, flipping they drug game on tilt. Cause in New York, dealing drugs is a sport. You either sell it, smoke it, shoot up or snort. Either way you're caught. And since I'm in it now, I'm in it to win it. Sky's the limit.
So now that we have our intercooler cleaned up, hit on the soft wheel, takes out, you know, any porosity, any dirtiness that's on the core seams. That's very important if you want to have a really nice core seam, in my opinion. And I also wiped everything down with acetone, so we have these wiped down. You don't want any fingerprints at all. Otherwise, when you're welding, you have fingerprints on there, it's gonna etch into the material and it's there forever. So if you want to keep that nice mill finish, you can either, you know, wear some, you know, gloves, clean gloves at that, and wipe it all down. Now what I like to do to make sure these pieces are actually even with each other, I'll take straight edge, butt it up against the ends of these, and then that'll give me my line. That's how I know that these are in line with each other. As long as these pieces are cut out exactly the same size and to dimension. Next thing I'm gonna do is I'm gonna fold in both sides up to 3.5 inch, as we're using the 3-inch piece for the outlet. And it's gonna give me a nice 1/4 inch on both sides to add weld to it. Another thing to be noted is I have to stay within dimension on this core, and I need these tanks to be 2 inches outwards. Now, if I'm doing a taper tank, they're gonna have to be a little bit longer, so I'm going 2 1/4. Now with them folded in, it's gonna sit right at 2 inches. If I were to stand them straight up, it'd be 2 1/4. So you need that little bit of height for when you bend them over. Next thing I like to do is put a piece across as another straight edge, and I'm going to come up here with a square, and at the bottom I'm sitting at 2 inches over here and 2 inches over here. Hey, 30-second off, which is okay. So next up, we want to measure this point to this point, here to here, all around to the parallels. And once you do that, you can start measuring everything out on your sheet and cut everything out. Another important detail is to make sure your grain is going the same way. You don't want this one to have a grain this way, then that way. It doesn't look that uniform. I mean, is it a big deal? Not really. But does it matter to some people? It does. So the easiest way to do this, to find the center, to make sure that these pieces come out symmetrical, is, you draw out your bottom piece, right? And then you figure out your height, draw your line across for the height, and then you find the middle. And then I know this has to be 3.5 inches. So what I'll do is I'll, start at the middle of my ruler, and I'll go out, 1 3/4 this way, 1 3/4 that way, to give me a total of 3.5. Now for these tapered pieces, what I did is, find the bottom, like I showed before. And you want to know that what your top's going to be, it's going to be 3.5. And then my height, X. So what I'll do is I'll draw a square out, and I'll find the center of the square, and then I'll go 1 3/4 out this way, and this way off center, and that'll give me the, symmetrical piece I'm looking for. I'm gonna go cut this out. After you get everything all tacked up, I'm gonna weld the inside of this tank. Normally I like to use 3/16 sheet, but with a 1/8 being a little bit thinner, even though I do get full pen when I don't weld the inside, I just want to be able to lay down some fat beads. So I'm gonna put in a very small pass on the inside throughout these tanks. What I'll do is I'll hit them with a cutoff wheel ever so slightly, tap it with a flathead, and then this will just pop right off. And there you have it. All right, so now we got both our tanks all tacked up, ready to get welded on the inside. And since I'm not actually a robot, we make mistakes. I had a little bit of a gap, and wanted it to be nice when I weld it, and I'm just filling it in. Very light filler, nothing crazy, just I'm gonna end up welding over that. But everything is all single pass. There is no double pass. There is no pulsing over welds. You want one continuous pass on everything. So before I weld anything on these, when they're on the intercooler, I'll weld across here and here, same for that side. And then I'll weld along here and tie in the corners. That gives a nice clean look. So I want to talk about tungsten for a couple minutes. When I'm welding these core seams up, since it's going to such a thick heat sink, and that's also 6061 aluminum, which is phenomenal for absorbing and dispersing heat, we're going to need all the amps possible. When you start to go past about 180 amps on any machine, your tungsten is going to get pretty destroyed. It won't be able to hold up to the amperage pretty much. So what we'll do is we'll step up to a 1/8, and for what I like to use is 2% thoriated. CK Worldwide has a laser tungsten. It's phenomenal stuff. It works great. So you could always use that as another option, but for me, my favorite is red, 2% thoriated. So use the 1/8 on the core seams. And then when I'm doing the tanks, I want more precision. So I'll step back down to the 3/32, and it does grow these little fingers on there, but don't be too concerned. It welds just fine. And that'll give you a really nice, accurate, weld and precise weld. And this is like about good up to 180 amps. So 180 max, and this is about 180 past. Go up to like 250, 260 on this until you start going to another size tungsten, but you would never have to go any bigger than 1/8, honestly. So here's the 3/32 tungsten, and then we use the 1/8 for the core seam. Now if I were to use the 1/8 on the tanks, it won't be as precise, and also those tanks are much thinner than the core seam itself, and there's not really much area of displacement for heat to go, so it's gonna end up shooting out a much wider, bigger arc and just throwing out too much heat, and it's not as stable when you're trying to go with lower amps. So you don't want to use 1/8 on lower amp stuff because the arc just isn't as precise and stable, versus the 3/32 being nice and stable at low amps. Another thing is I end up using this large cup on this side. Now it's a little wish-washy, as you can see along the core seam. Sure, the tanks look, they're nice, don't get me wrong, but it's not as precise. The arc was also going all over the place, and for that tank I ended up using pure green tungsten where it balls on the end, and honestly the arc just likes to shoot out wherever it wants to go. So that's why I don't like to use pure anymore, and I didn't find the red until I got to the other tank. And then I'm stepping down to my normal number 5 cup, but just because the way this was shaped, I was a little skeptical on how well it was gonna weld and, throughout the argon. But it actually ended up working out very nicely. So with this, it's gonna allow the arc to travel in a wider area to where a smaller cup contains the arc better. The smaller you go, the more the arc is contained and focused. Well, number 5 seems like a really nice happy medium for doing intercooler tanks, and really honestly anything else. And you don't need to use the gas lens either. Like, there really isn't that much of a huge benefit. I'm just so accustomed to using it. That's what I just kind of stuck with. So number 5, lens or without, great. Big cup like this, you don't want to use that. So for aluminum, I like to keep it short, stubby. Last thing is, I don't like to sharpen too much of a point on my tungsten for aluminum. Some guys like to put a little flat on the end, which helps the tip not split or pretty much disintegrate on you and pop off into your weld, which it can happen occasionally. But if you do a nice short stubby point, to the tungsten, it will stay much more rigid. It won't fall apart. It will last longer. Versus if you were to do a really sharp point, like if you're doing some DC welding, doing any stainless, titanium, etc. If you do a sharp point for something like that, where it's almost like a toothpick, the tip's gonna get annihilated. So aluminum, short and stubby. Stainless, you wanna go like a toothpick pretty much. So if it was stainless, you'd wanna go about a 1/4 inch total length, and then a nice fine point. Here's the wheel that I was talking about previously. I'm sorry you guys couldn't see what the actual brand was. Amicupid, Amicupid, however you want to say it. It's hard, but it's still a soft wheel. 180 grit. You can get this on Amazon. I'm sure plenty of other places sell it. It's a nylon fiber wheel. I mean, they're like 10-15 bucks. They work awesome. And honestly, sometimes I'll even clean my tungsten up on this, vertically of course, but just like a tiny bit, you know. If I'm doing really fine stuff, like really thin stainless, or if I'm doing titanium, I don't want any type of porosity on my tungsten. Granted, they sell tungsten grinders with diamond wheels. They have acid dip. People like to use grinding stones, but personally, I've always found my luck with using 120 grit, you know, sanding paper on a belt that's used, and it, you know, as long as it's not dirty and full of shit, it works great. But I'll hit it on that, and then I'll go to this. I want to talk about settings, but there's not really too many settings on this machine. So for my intercooler cores, I know I'll do 230 max on the core seam, and when I'm doing the tanks, I'm about 150 to 175. Balance 65. Post flow, I mean, you don't really need it high at all. There's no reason for it. I'll go a little past 6, just in case the tungsten is smoking red hot and you don't want it to cool down and having you know, oxidization happening. So that's really it for this thing. I mean, there's no pulse settings, there's no crazy settings on it. You can't change the frequency on it. So balance, post flow, amps, I mean, that's all we're really working with here. This machine's from I think the later 70s, I believe, or early 80s. But these Miller Syncowaves are phenomenal machines. They're transformer machines. It's basically like a giant transformer on top of your power lines. And they conduct so much heat, so much amperage. So they're really great workhorses when you want to do a lot of industrial stuff, you know, welding, fabbing all day long, nonstop. You know, the duty cycle, I believe, is 80%. So 80% of 1 hour, you know, what is that, like 45 minutes or so? You could run max amperage for 45 or so minutes on this machine. And a lot of newer machines these days that are inverter type machines, to where they don't use as much electricity, but having the inverter system in it, it's able to, you know, put out a lot as well. But their duty cycle isn't is as high. And you know, I think a lot of them are around 40 to 65% of 1 hour. So it's not as much as this machine. And a lot of machines usually cap out at 200, 225 amps. I mean, there are bigger machines, of course, but those, you know.
Come with me. simply look around and view it.
We're all finished up. I wanted to just go over a couple things. This is a 18 by 12 by 6 Vibrant Performance intercooler core. Great company, great customer service. Always enjoy welding their products. And just in case you didn't know, all these cores are 6061 aluminum. Combined with using 5052 sheet with a mill finish, which makes things look really pretty on a car. As long as you don't get fingerprints on it before you weld it all. Use 5356 filler wire to get that nice shiny welds. And out of the inlet, the outlet, decided to bead roll the inside just to have it kind of have a surface to sit on. I never done that before, and don't mind it. It's a little bit thinner to weld, a little more tricky to weld. It kind of bulges out, where I kind of like having more of a concave bead around here rather than a convex. I mean, there's plenty of filler wire in there anyway, so I'm not worried about it being concave. But aside from that, this is pretty much it. I'm gonna leave the bungs for the customer to add on, or brackets, whatever you want to do. I'm not really sure how the intercooler core is gonna sit in the car, so I'll leave that up to them. I guess another thing is, before you weld the whole intercooler up, and these seams being the hardest to weld since this is such a giant heat sink, and if you don't have a strong enough machine, let's say you're limited at a 200 machine, what you want to do is tack the tanks on, weld the tanks, both sides. The core will be blazing hot at that point. Then you can go ahead and you can wrap the seam all the way around, and it should weld quite nice. Versus trying to weld the tank, then go into the seam right after. I mean, sure, this will be heated up and not as hot as if you were to do both sides. So it's like a little trick you can do there to make things easier for you. Otherwise, you can stick it in the oven, or you can use a MAP gas torch to heat up the core seams as well. But in my opinion, just welding the tanks alone will do enough justice. So I think that wraps things up here. If you guys have any questions, feel free to leave a comment and ask, and I'll do my best to respond. This is my first video I'm ever making on YouTube, aside from car stuff. So hope you guys enjoyed some of the information. This is not anything crazy. I don't have the best equipment. I'm using an iPhone 7, so please bear with me until I get a GoPro. And yeah, that's it.